Hi, Rich Strania here with TMC. Thanks for watching. We're in San Jose all week. We're interviewing a number of companies in the area. On our program is Al Wegener. He is the CTO and founder of Samplify Systems. Al, welcome back to the show.
Thanks, Rich.
So for those people who may not be familiar with your company, you want to just give us the brief overview?
Sure. We were founded in 2007, funded by two venture capital investors, Charles River Ventures and Formative Ventures. And we had a second round of funding that closed in February of 2011. The new investors there were the semiconductor company IDT in San Jose, and also the oil and gas exploration company Schlumberger. What our mission in life, what Samplify's mission is to reduce bandwidth and storage bottlenecks wherever they happen. We started off by reducing the bottlenecks for data acquisition. So this is a kind of an esoteric area, but wherever you have real-world sensor data, it has to be captured with an analog to digital converter, and then it needs to be typically transferred somewhere and stored. What this has in common with what Samplify is doing today is when you look at multi-core CPUs, such as would be in your Apple iPhone or the tablet, there are many cores there that are doing processing, and they have to get data from the outside world. The outside world means memory or disk drives. And what Samplify's technology does is it makes that data smaller so that the cores can process it faster.
So you have a really unique group of investors. I don't think I've ever seen a group as unique as that, from Schlumberger, oil exploration, to chips, to traditional VC firms.
Well, let me try to pull the thread together. What our strategic investors have in common, I'll mention one other investor is Mamiya, which is a high-end digital camera company in Japan. They have a bandwidth bottleneck. Schlumberger's bottleneck is in two places. They have ships that go across the Gulf of Mexico collecting data, 2 terabytes a day, and after 8 weeks of prospecting in the North Sea or the Gulf of Mexico, they take that data back to their supercomputer center, and by that time it's 100 terabytes, and then they have to distribute that over thousands of Intel cores to do their processing that finally results in a 3D model of the Earth. And then that model is what ExxonMobil and Shell, the oil companies, use to figure out where to drill. So that information is important. So the volume of data that they're handling and the fact that all of it is numbers is what we do for Schlumberger. We make their floating point numbers smaller so that they can get their oil and gas answers faster. The company Mamiya, instead of doing a 10 or 12 megapixel image sensor, they're working on 50 and 100 megapixel sensors. Obviously, it takes a lot more time to move that much data off an image sensor without compression than if you could compress it. So Mamiya is also using compression to get the data off their image sensors faster. IDT partnered with us actually a little before 2011, and they're in the wireless infrastructure business. So they make chips that go into base stations. And there, with the advent of 4G wireless, we're moving from 3G wireless to 4G or LTE. Base stations are starting to have more and more volumes of data. Whenever we do our browsing on our iPads, we expect instant response, and we're sending a lot of files back and forth on the wireless link. On the fiber optic cables, it means that they have to go from 3 gigabits to 10 gigabits. 10 gigabit fiber is a lot more expensive in a base station than 3 gigabit. So if you could get 3-to-1 compression, there's a big value prop there. So that was the reason that IDT invested.
That makes all of that makes a lot of sense. So question I have is, what's been happening in the company lately in the last year? Are there some new things that you can tell us?
Yes, the new technology we're working on is called APAX, A-P-A-X, and it stands for Application Acceleration. Rather than talking about the technology, which is compression, we talk about the benefit, the fact that your applications on cell phones and tablets will run faster if they're not facing these I/O bottlenecks. We have a two-pronged strategy to get these products to market. The first is a software product, and the second is a hardware product. The software product allows people to try APAX on their computers, on their signals. It doesn't matter if it's Schlumberger or Mamiya or IDT. Whatever signals you have in the form of numbers, integer or floating point values, can be compressed by APAX, and you'll know how fast and how well that compresses just by using our software. The software may be limited to maybe 100 million numbers per second using one Intel core. So if you need to run faster than that, then you should get our hardware solution. And ultimately, this hardware is very efficient, very small. So companies that are building chips like Apple and Qualcomm and NVIDIA and Intel, they can integrate our little IP block, intellectual property block, on just a tiny piece of their silicon, and they can get the benefits of this at much higher speeds than 100 million operations per second.
So really the application is for virtually anything and everything, because you've got the software and the hardware solution, so you can shrink it down if you need to, and you can also use it in very large systems.
Yeah, let me put a just slight tweak on that, which is this is a numerical compressor. So wherever you have integers and floating point values, that seems to be kind of esoteric, but let me give examples of what that is. It's everything in supercomputing.
Sure.
It's every image processing application. It's graphics, which is already using some compression. So basically, wherever those integer and floating point arithmetic is happening, this is a place that APAX technology can accelerate the I/O around the arithmetic.
Now, what's next for the company?
What's next is probably in September, we'll be announcing the software product, APAX and software. And 3 months after that, by November, December this year, we'll be making the RTL available, so the IP block. And this should be interesting, as I mentioned, to companies like Intel, NVIDIA, Qualcomm, and ARM.
Fantastic. Thanks for being here today.
All right. Thank you, Rich.